Welcome to the brakes engineering video. It's going to be a little bit of engineering in here, and the goal of this video is so that you can figure out on your own what you need to do to your brakes to make them better. All kinds of people are always complaining about their brakes, having issues. So we're going to go through some stuff, but we got to start with basically what are the brakes doing and what's happening. When you stop a vehicle, there's two things you're stopping. You're stopping the weight that's moving forward, and you're stopping what we'll call the kinetic rotational energy of the tires. And the reason the kinetic energy of the tires is important, and it's not just the weight of the vehicle. If you've ever ridden a motorcycle, you feel that kinetic energy as you start to turn, and you feel how it, when you take a bicycle wheel, you spin it. There's a lot of energy wrapped up in the rotational speed and the weight. The bigger the diameter, i.e. you go from 31s to 40s, the more energy you have tied up in that rotational, and the heavier they are, the more energy you have. And quite frankly, those energies are sort of, they're not just linear. It's not if you make twice as big if the tire is twice the diameter, it doesn't have twice the kinetic energy. It has more like three or four times the kinetic energy, a lot more. And I'm not going to get into all the math, we can do all that, but it's basically, you start out on a 31-inch tire, it's about 50 pounds. You get to 35, you're probably up around 100 pounds. When you look at it from a Jeep perspective and what your brakes need to do, when you go from a 31 to a 35, you've added, 50 pounds per tire, which adds up to 100 pounds. So 50 times 4, and then your energy gets to be essentially about triple that. So it's really like adding 600 pounds of weight to your Jeep when you put a 35. When you go to a 40, like my tires, and you get up around that 150 pounds, it's really like adding 1,200 pounds of weight to your Jeep from what the brakes have to do to stop your Jeep. So, this is one of the things you really got to think about is, added weight obviously hurts your Jeep. The skid plates, the bigger axles, all the stuff you do that adds weight, the big winch in the front. But also as you go to these big tires, there's a multiplying effect, And the other thing you got to understand is that speed, the reason I say speed kills, if you're going 30 miles an hour, you're going to have some amount of kinetic energy that your brakes need to stop, and that certain amount of energy stored in your vehicle that, when you get into a crash or hit something that's going to break things. If you go to 60 miles an hour, you double your speed, you have 4 times the energy. That's why it's so hard in those rock bouncing and in rock crawling to really get any speed going. Because when you're hitting stuff, when you hit it at 10 miles an hour, there's a certain amount of energy and force that your Jeep needs to hold itself together. You increase that to 20 miles an hour, you need 4 times the strength, to survive the same hit, so to speak. And that applies to brakes as well. So, and this is why, they say speed kills, because you have that extra energy. Extra energy can be bad when you get into an accident. So, for example, a stock Jeep is about 3,500 pounds. I went up and I added a bunch of stuff. Mine weighs 5,300 pounds. Of that 5,300 pounds, about 400 pounds is in, that extra wheel weight. And really that means from a 3,500 pound Jeep stock, I'm at really, with the rotational energy of the tires, it's really acting like my Jeep weighs 6,100 pounds. It's almost double. So, in my case, I need brakes that are literally twice as good, as the ones that were stock to get the same. All right, got Matt videoing today, helping me out. This is part of our brake video. What we're going to do is talk real quick at the front of this video about some of the things you can do to upgrade your brakes on your TJ. I'm going to show you a few things. I want to do some comparison between his Jeep and how it brakes, and my Jeep and how it brakes. First thing I'm going to say is his Jeep is still fairly stock. He's got 33-inch tires, and he may have needed like a small bump in braking improvement. And I think you went with the Black Magic brake pads and some upgraded discs.
No, I believe they're the Power Stop.
Power Stop. Okay, so those are better. Those are typically what those are. They're brake pads that have these holes so they cool faster, and they also have probably a metallic finish. They're a metal brake pad. They have a higher coefficient of friction. So for the same braking force, we'll call that clamping force later in the video, that you're going to get better stopping. So we did that at all 4 corners.
All 4 wheels.
And you can lock it up pretty easily. You said
yes.
Get it to lock up. All right, so that's a good thing. He doesn't need to mess with his stock proportioning valve because he hasn't changed the front to rear ratio. Now, I've done a bunch of stuff. My Jeep weighs easily 1,000 or more pounds, and it is probably closer to 2,000 when you count the tire weight and all that stuff. So my Jeep weighs a lot more. So I'm just going to sort of put a comparison here. You know, these are pretty close to the brake pads I have on mine. Here's his Jeep, and he's locking them up, and that's all you really need to do. So now let's go look at my Jeep. My Jeep over here on 40s, 1-ton axles. You know, I'm going to hold the same brake pad so you can kind of see the difference. So I'm running here on the front F350 dual caliper or dual piston calipers on really big 13-inch brake rotors on the front. I have also gotten rid of my stock proportioning valve, and you can see that I've replaced it with this T. Now this is to the front brakes. This first part of the master cylinder goes to the front brakes. I've replaced the stock master cylinder in the Jeep. I had the same one he did with this Dodge 3500 master cylinder, and it flows a lot more volume for these larger brakes. Later in the video you'll see from some calculations I did that maybe I might even want to go to a little bit smaller master cylinder. On the rear brakes here, I've got this adjustable proportioning valve. You can see I can turn that in and out, and that balances the front brakes to the rear brakes. And so one of the most important things you want to make sure when you're working on your Jeep is that you keep the front to rear balance correct. What you don't want to have happen, and if I didn't have that proportioning valve, what would probably happen on this Jeep is those rear brakes would lock up long before the front brakes got the full power they could do in braking, and I would lose control. So you want to have, you know, your front brakes and rear brakes dialed in so they lock up about the same time. That's how his Jeep's going to work, because the factory programmed it that way. This proportioning valve allows me to dial it in. As I open it up, it allows the brakes on the rear to work more, and as I close it in, it reduces the pressure to the rear to sort of, so I can balance front to rear. And that's an important thing. As soon as you change the size of the caliper piston or go to a bigger brake kit, or if you went from drum brakes on the rear and put a disc kit on it, any of those things, this is a cheap upgrade. I pulled that thing out, bought this and the fittings for like 65 bucks, and it really gives you some tunability on your brake system, so that's a great thing. On the rear, we got Dad walking by over here, so let's go to the rear of the other side. On the rear, I did another popular upgrade. So I got the 14 bolt, and I knocked Dad over here. So this is a 78 Cadillac Eldorado brake, and it's really a standard Chevy brake type brake pad. The one thing that it has that's really cool is it has a built-in emergency brake lever here on the back. So if you came over here, if you can come and show this lever. So when I get my emergency brake hooked up right, it'll pull up on this, and that'll allow me to have an e-brake for the rear. And that's why these Cadillacs have this extra emergency brake feature are really popular. So that's kind of my brakes. These are on standard Chevy 12-inch rotor. The Jeeps have 11-inch rotors. You know, the couple of notes, you know, when you're running the bigger tires and you have the greater weight, you need that. The real trick to making the brakes, you know, you might think that my brakes work better than his because they're much bigger. That's not the fact. Actually, I'm still trying to dial my brakes in. I think his brakes probably work better than mine, not just because I have a heavier vehicle, because I probably haven't gotten my the ratio of sort of the size of the rear and front calipers put together, along with the size of the master cylinder and the piston in the master cylinder correct, to get the optimal braking out of this system. Now I will get there, and I will say it's getting a lot better. I'll also say I made one of those really dumb mistakes. I've had these rear brakes on for a while. If Matt will come over here, I want to show you guys something. So I chased this forever. Here's the bleeding valve, and you might all laugh at me and go like, well, that was really dumb. This is where the cylinder is. what I ultimately figured out is when I installed these brakes, this bleeding valve should have been facing up more. And when I would bleed the brakes, it left a little bit of air in this cylinder. And I was forever messing with this thing, trying to bleed it, and still had a mushy pedal. And I thought, man, I have this huge, and I kept getting bigger master cylinders because they said, well, you get a bigger master cylinder to get rid of mushy brakes. First, you got to make sure you can bleed your brakes correctly. So I take credit for that faux pas. And hopefully now that I've got that corrected, it seems to be braking much better. And I'm going to continue to dial it in and get the right size master cylinder till these brakes work the way they should. Okay, before I go on to the next more detailed explanation, just want to make sure we're all clear on, you know, sort of how a master cylinder caliper is a force multiplier. So let's just say we had a 1-inch area, you know, the circle in your master cylinder is 1 inch, and you push on it with 100 pounds of force. That pressurizes everything on the inside of this hydraulic system. So you have 2 front wheel cylinders and 2 rear wheel cylinders. You know, it pressurizes those to 100 pounds everywhere in there. Now let's just say that, as is normal in braking systems, that the area of the pistons is around 4 inches. So you have 4-inch piston here, 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 and here. Now what happens is when you press on that brake pedal, because everywhere in the system, once you've filled up all the voids and the brakes have pressed out and there's no more room for the fluid to expand, that will apply 100 pounds per square inch times 4 inches, or 400 pounds of force at this wheel, this wheel, this wheel, and this wheel. You add those together, 1,600 pounds. So you've taken the pressure from your foot of 100 pounds and you've multiplied it into 1,600 pounds because the small area here that creates the pressure applied to the big areas here adds up to a massive, what we call force multiplier. The only limiting factor being that if you can't fill up all those voids first, you'll run out of brake pedal before you get to really build up that pressure. That's what limits it. So when you start thinking about, oh, I've got 100 pounds pushing with my foot, and then you add in the brake pedal of a multiplier of like 4, and then you add in the multiplier that the power assist adds to you, you know, your 100 pounds of force from your foot not be 1,600, it might be 5,000 or 8,000 pounds of force. And that's where the brakes really get all their force. But this is that multiplying force. And what we're going to talk about next is the ratio of the size of this little piston in the master cylinder versus the area of all these brakes. And I'm going to do a couple real world demonstrations, one based on matched Jeep, a stock TJ Rubicon, and one on my sort of highly modified one, and compare what happens when you switch all these components around. Okay, so we continue with our brake video. So we're going to talk about how do you turn the power of your foot and what you press on the brake pedal into enough force to stop a car. And obviously, can't do the Fred Flintstone and stick your foot down there and stop your car. So you know there's got to be some force multiplication. So we're going to start talking about the things that multiply the force of your foot pushing on the pedal of your Jeep to be enough to stop your Jeep. So here's our pedal. First thing you know, this is pinned at the top. So this is kind of your brake pedal assembly. It's a piece of metal and it's pinned at the top, and here's where you push on your feet. And let's just pretend, you know, for example, we're going to say that you're pushing on the brake pedal with 100 pounds of force. What happens? Well, there's a distance here from the pin to where it starts to push on the rod that goes into the master cylinder. Now, typically, the distance from where this rod is to where your brake pedal is 3 or 4 or 5 times longer than the distance from here to the pin, and that creates a multiplying factor. So if you push with 100 pounds of force here, and it's pinned here, and this is 4 times as long as that, you end up with 400 pounds of force going into the master cylinder. And that's just a simple, just like a wrench, you know, anything you put a big pipe on or lengthen up or use a bigger tool on, you know, you're using leverage to increase the force. So that's where it starts. Then it goes into the master cylinder, and that pushes fluid out to the brakes. what limits us here? There's a couple of things that limit us. So you go like, wow, if I had a really long brake pedal, and I could take my brake pedal and extend it down and make it 6-to-1, I could have 600 pounds there. And you could actually do that. I could move my rod up here, and that would also make the ratio much larger, and that would give me more force. The trade-off you have in the pedal system is how far it can travel here and pushing into here before this pedal, essentially hits the floorboard. So you're going to get about, typically what happens in something like this, if you get 6 inches of travel here, or let's say you got 8 inches of travel here, you're only going to get 2 inches of travel. Really, a lot of them are like 6 inches of travel on the brake pedal, and you get about 1.5 inches worth of travel on the piston into this reservoir. That's the same as this piston into that reservoir. And you say, well, why is that important? So, for one thing, there's a balance. You need to be able to push into that reservoir far enough to actually, push these out and push this out. And when I talk about far enough, so let's just say that we pushed this piston in 1 inch. How much fluid would that displace? It would displace 1 cubic inch, so it would displace 1 inch cubed of fluid. Okay, so you've displaced 1 inch here, and you've moved this 1 inch, which is 3/4 of the way or of what a normal brake pedal will go. How far are these brake pistons going to move out in response? Well, okay, you've got to move 1, 2, you actually have to move 4. So if you had to move 4 and they were each 4 inches, so we only have 2 in the drawing. Well, let's say every car has 4 brakes. So you've got 4 inches, 8, 12, 16 inches. Okay, so if I have 1 inch cubed and I need to divide that essentially by 16, essentially you end up with 1/16 of an inch that this will move. So you can press on this, displacing cubic inch of fluid, but you're only going to ultimately displace these brake pads a tiny amount, 1/16 of an inch. Now, I think you can understand that there's a problem there. You need to be able to push enough fluid to push these maybe more than 1/16 of an inch or around that. Brakes are riding pretty close. They're designed to not have a lot of slop, but there's other things that happen. You have you have a little bit of expansion in the lines, particularly the rubber or stainless steel lines that you use. Stainless steel are better than rubber. If your brake is sitting a little farther away or backs off more than it should, if you have a little air in the system, a lot of that stuff, that's why brakes go bad really quickly, is because the amount you can move in this master cylinder is not going to move these brake pads. Now, they pretty quickly clamp and build up pressure, but you can see that you can't just, because of the amount that you can push here, the distance you can move it, you have to be careful in balancing. So when you're designing your brake system, here's what people do in the Jeep TJs. They say, well, I'm going to go to bigger brakes. What do they mean by bigger brakes? They mean that you have a bigger area in the caliper generally. There'll be dual calipers, or there'll be some other version that increases that area. And they say, well, you need to move bigger fluid. So I showed you, here's my old Jeep master cylinder, and it's got a little small, this is actually about 7/8 inch cylinder diameter. I can calculate the area. This is the often talked about Dodge 3500 master cylinder. And you can see that this piston is much larger. Now we're going to get into more of the fact that there's 2 pistons in here and how much it moves. Fortunately, in this situation, the stroke, how far it moves, is the same. But when you push this one in, you move a lot more fluid, which means you can have bigger brakes, bigger calipers, and you can get more surface area. There's a trade-off to that. So if you go from a 7/8 inch piston here, and let's say a 7/8 inch round piston is, let's just say that turns out to be a 1 square inch. It's not going to be that much, but let's say a 1/2 square inch. And then you go to this one, which is a bigger diameter, 1 1/8 inches. You have a much bigger piston, you can move a lot more fluid, you can move these out better. But as soon as you increase this, if let's say you double the size, let's say this one has twice as much surface area in the 3500 as you have in the Jeep stock one, you end up with half as much pressure in the cylinder because this 100 pounds turns into 400 pounds. It doesn't turn into 400 pounds up here, it turns into something less as you go to that much larger cylinder. So that means you have less force here. Now, if you have bigger area, it can kind of balance out. That's the balancing act you're looking for. Is something that moves enough fluid in the master cylinder that it matches up with the brake size, the caliper size, so you get the same amount of clamping force or a little bit greater clamping force. Generally, that's what you're looking for, is something that has more clamping force, but it doesn't bottom out. When I say bottom out, if you put too big a brakes on here, you can push all the fluid out of here and it doesn't really build up enough pressure and fill up all the voids and push these out enough to really break your vehicle. And that's when you feel that spongy feeling, or like just boom, you hit the brakes and they bottom out, or you have to pump them a couple of times. Oftentimes that can be because, you know, you have too small of a master cylinder and you're not displacing enough fluid throughout the system to really push the brakes to full capacity. So there's a lot of people that do a lot of things. Generally, if you've gone to 3/4 1 ton brakes, it makes sense to go to a 3/4 1 ton master cylinder. If you've just gone to some high-end brakes that are really, let's just say a Black Magic brake that's a direct bolt-on replacement, or an Explorer brake on the rear that you're replacing some drum brakes with, you know, generally a decent stock master cylinder is going to keep that pressure high, and it doesn't make sense to go to that big master cylinder. Okay, this is Ray Bestos. This is where I get my brake information. So I go to their catalog and I go to their search, and then over here you can do part, VIN, application, you know, so we can just do something quick here, you know, just do an application, year. I have an Matt's got an 04. We're going to search, and we're going to get all kinds of TJ parts. Then you're going to come down here, you're going to, oh, what do I want to look at? Let's look at brake calipers. So we're going to take a look at some brake caliper specs. So right front, let's just look at this one. What do I want to know? Here's some images. Piston caliper piston diameter, 2.598 inches. Okay, so that's an important piece of information. That tells you, eventually from that, you can use some quick math and find out what the area is. So I'm gonna write that down. I'm gonna call it 2.598. And those are the front. And then I'll go back and I'll get the diameter of the rear. And then I'm gonna go in and I'm gonna look up the master cylinder. Let's see if we can find that. Well, there they are, master cylinders. Let's get that up there. And let's see what we can find. Okay, there's a master cylinder. And when you look at the master cylinder, you can find out that the bore diameter in a TJ is 1 inch. Now these, I'm going to show you in a minute how you use this information, and I got to get the diameter of the rear cylinders, and I'm going to go ahead and I'm going to do a video, and I'm going to show you how you take this kind of information to sort of calculate what the percentage increase in force from the master cylinder to the brakes is, and why that's important. Okay, so now we get into the real fun stuff. Probably most of you will want to stop watching at this point, because this is a bunch of math and engineering. But if you really want to understand sort of how you might look at your own system and do some calculations to figure out if your master cylinder is too big or too small, and how you really want to size it, I did a quick comparison of, I guess I shouldn't say quick, of Matt's stock Jeep Rubicon versus my modified Jeep. And so we're going to start by talking about, I think I've already shown you a video, where I talk about how the force on the brakes is equal to the area of the pistons that are in the calipers, multiplied by the number of pistons, and then, that's the amount of force in the system to be applied is given by the master cylinder. So I did this thing and I said, okay, how would you calculate that? I went on, I've also showed you how you can go get all the little diameters on the Ray Bestos catalog. So this is what you would do. You have the diameter, the radius is the diameter divided by 2, so you go, pi r squared is the area of a circle from basic math. So you can say, okay, to simplify it, if you really want to do it, the area of a circle is pi, approximated as 3.14, times the diameter divided by 2, times the diameter divided by 2, So we're going to look at what that means in a stock Jeep Rubicon. First, we're going to compare the master cylinders. The master cylinder, you need to know the area of that little circle. Little circle inside the master cylinder. I can probably show it to you. You've seen it a couple times. I pulled it out. 3.14, it's a 1-inch diameter, so it's 1/2 times 1/2, which is the same as r squared. So you have 0.785 of an inch of area. Okay, now, in my Jeep, I have a master cylinder has a 1.313 diameter, so it's not really that much bigger, but what that results in, because the area is the square, 0.785, the diameter of mine is 1.35. Now this 1.313 is a pretty big master cylinder. There's a couple sizes in between these two that I could use. This is about the biggest one you could use. And you'll see ultimately that I'm probably going to use a smaller one. The reason for that is what am I losing in that master cylinder? So if I push on the brake with a certain amount of force, and how does that force get translated into the fluid? Well, it's the area of the piston divided by the force. So you can sort of say, well, you can do some math, but essentially I did some math and I said, wow, by doing that, this difference in area, 0.785 of an inch versus 1.3, I've lost 41% of my area. What that really means is I have lost, for the same amount of pressure, I've lost essentially 41% of the pressure on the fluid in the system, which is 41% of my braking. So I have dramatically decreased the amount of braking pressure that's being applied to the brakes on my Jeep. Well, there's something that can offset that, and that is if I have much larger pistons, it might be that if I have these much larger piston areas, that a lower force times that greater area could equal the same, less, or more actual braking force at the wheels. So I had to do this. I had to go through the front of his Jeep, and he has a 2.6-inch diameter piston on the front of his Jeep times 2, one on each side, and he has a 1.88-inch diameter piston on the rear. He has 2 of those, and you say, okay, the total area is 16.14 inches. So really, what you're doing is you're making a large pressure with this 0.785, like pushing on it, and then it gets applied over this large 16.14 inches, and that is what gives you your clamping force. In my case, I have dual caliper pistons up in the front, so I go, oh, okay, that means I got to go 3.14 times radius squared times 4, not 2. And in the back, I have a 2-inch diameter. So it's a little bit bigger in the back and a lot bigger in the front. So I have 15.2 square inches of area in the front and 6.28 for a total of 21.39. So rough mathing that, 16 to 21 really means I've lost about I gained about 25% in pressure, because you have these bigger cylinders, it means more pressure. So I lost 41% by going to a bigger master cylinder. I gained 25%. So 25, 35, You know, so overall I've lost about 15% in sort of braking capacity for sort of the same amount of force. I went into a calculation and just basically said, well, what would happen if I managed to get, you know, the same force on the brake? Now, in my case, I would have to push harder with my foot to get to 100 PSI, but I ran the calculations for 100 PSI in the brake cylinder. On Matt's Jeep at 100 PSI, it'd get 2,081 pounds of force based on the area. That's, you know, 100, basically that's 100 PSI times 16.1, oh no, you got to calculate the size of the piston. So yeah, so I guess you could just say, yeah, it comes out about, oh boy. Well, let's cut this part out. Okay, so I did a calculation, and essentially I came up with, for about the same amount of force, Matt would get a couple thousand PSI, the same force with your foot, and I would get about 1,584 pounds of pressure with the same pressure applied with my foot. Now what that takes into account is both the different master cylinder sizes and the amount of brake area. And you can see that, you know, 1584 to 20, it's about a 25% reduction in braking force. Obviously, because I'm using such a large master cylinder, I'm thinking that I might go down to there's one that's 1.125, that's inch and an eighth. Master cylinder, I think can be bolted up to that TJ, and I might actually go try that one and see if I get enough volume out of it to get the brakes to work right, in addition to having, you know, that would actually make this more like 20%. I think my braking capacity would be pretty close to what Matt's is, and I think that would help me. So all in all, one of the things you want to look at, you know, and this is where people get mixed up when they're adding these larger brakes, is really looking at, like, how do I pair a master cylinder with a set of disc brakes on all 4 tires? And this is one way to look at it. There's another important sort of math thing that comes out of it, and that's the front to rear ratio. If you notice this, I've got, you know, of this 16, I've got about 1/3 of it in the rear and about 2/3 in the front. Over here, I've got about 75% in the front and 25% in the rear, or close to that. So one of the things I noticed, and that's why you have to have that brake adjusting valve, the proportioning valve, is the area in the front to the rear is very different on this than on stock. So the stock brake proportioning valve is designed to compensate for the difference in area from here to here, which is very different in the surface area from here to here. So when you're trying to dial in aftermarket brakes or larger brakes or different combinations of brakes, this difference is going to tell you, like I should have, you know, you'd like a lot more braking in the front, so it's good that I have a lot of area in the front for strong braking, but I got to make sure that I don't inadvertently lock up the rear brakes too soon, or have too little braking in the rear, so that I have to, you know, so that I can't even lock up the brakes in the rear. So these are things to look at. That proportioning valve is what will allow you to get this balance front to right correct. This is just sort of a number to look at. Probably would have been happier if it was closer to stock. I think that might have been a little better for me, but it is what it is, and I'm gonna live with it. Like I said, I'm probably, having gone through all this analysis, I'll probably try that 1.125", which is somewhere between the 1-inch master cylinder comes stock and the 1.3-inch one that I'm using currently. And so you can do this math. Sorry if this is way too engineering, but certainly it's useful information, and it helps you figure out, you know, what might be going on in your braking system.